Okay, let us see now, let us go a bit further when we see how we can get force and then ask power of a particle. So from here, I understand a particle of mass 4 kilograms has its position vector at any time t given as that. You see they are giving us it as a vector form, to us as a vector form. Find its acceleration after time t 2 seconds, force acting on the body after t 2 seconds, and then power developed after 2 seconds. So we know that to get acceleration we need the velocity, and to get velocity we need the displacement. So we have displacement, so we can first get velocity, then after getting velocity we can come and get our acceleration. So from there, we know that our v is equal to the derivative of the displacement. So d dt will be equal to then 3 minus the cubed. So from here you can able to see that r velocity is going to be, and this way this will get 4t, and this way this will get negative 3t squared, and these are meters per second. So that is our velocity, but then our acceleration is d dv dt, which will be d of the velocity, which is 4t minus 3t squared. And so there our acceleration at any time t, initially this will get 4, initially this will get negative 6t. So after having that, they ask you find this acceleration after 2 seconds. So when time is 2 seconds, then our acceleration after 2 seconds is going to be 4, then negative 6 into 2, which will be 4, negative 12, which we can ably give as 4i minus 12 meters per second with its. Okay, so after that, let us find the force acting on the body after 2 seconds. So in our part B, know that force is equal to mass times acceleration. So we have our force as, we first get its vector form, which will be the mass, which is 4, then times the acceleration, which is 4, then negative 6t. So our force here will be 16, then negative 24t. So the force after time t, our force when t is 2 seconds, we have 16, then negative 24 into 2, which will be 16, and this will give us negative 48. So the power developed, okay, in our part C, okay. So our force there, we can set our force after 2 is going to be 16i minus 48j. Our force of course measured in newtons. When it comes to part C, know that our power is given by the force dot the distance over t, which is said is the same as f dot s over t, and displacement over time is given by to be our velocity. So our power will be the force dot v. So we need v after that time t. So our v after time t, we need this v after time t, and then our force after time t. So meaning our power when t is 2 will be force when t is 2 dot velocity when t is 2. But our velocity at n time was 4 minus 3t squared. So when t is 2, so our velocity at time 2 seconds will be 4 into 2, then negative 3 into 2 squared, which would be 8. This would be 4 times, which is negative 12. So meaning that our power will be now, our power will be our force, which is 16, negative 8, dot 8, negative 12. So in all those two things, we have 16 times 8 plus 48 times negative, and the answer will be in watts. Be 704 watts. That's going to be the power generated. All these we are deriving them from the general equations we saw for power, for displacement, time. Those are the things we are using here. So that our power is the rate of change, it's the rate at which work is done. So their formula is for work done, as simple as that. So when these ones, it means that now we had to have covered the other previous topics of work, energy, and power. So that's it. I wish you well. Alright, don't forget to indicate the units.